Okay, so sorry that last example went so long. These Laplace transform problems are really long, and I'll try to be a better judge of like good breaking points for those long problems in the future. Before I move forward, I wanted to kind of recap what happened in this one, because since they're such long problems, I know that it's easy to lose track of what's happening in them. So just real quick to summarize what we did. We took the Laplace transform of both sides, just like you would when you're solving any Laplace transform problem. Left side was nothing unusual for us. Right side, we had to use the new property that we learned. And because we used that new translation property on our forward Laplace transform problem, we knew we were going to need it on the inverse Laplace transform problem later. We solved for capital Y equals some stuff, and we wanted to compute the inverse Laplace transform to find little y. But we don't know how to take the inverse Laplace transform of those functions without using our new property. So what we had to do was we had to rearrange the whole equation so that it included this similar term, s minus 3 everywhere. Because we already saw it in the denominator, but it was missing from one of the numerators. There was no s minus 3 term. So we did that clever algebra so that nothing changes about what we've written, but we've written it using an s minus 3. And then from there, we could break up all the terms in order to take our inverse Laplace transform. The ones with higher powers, 1 over s minus 3 to the fifth and 1 over s minus 3 squared, those were where we had to use our new property. And so what we did was we identified which power we were looking at to figure out what our little f would be, and what should be in the numerator of our capital F. And then we kind of tried to make what's inside the curly brackets look exactly like something from our old Laplace transform table, just with s minus 3 instead of s to the fifth. And then we divided by whatever number we had to use to make that happen. And then from there, we could apply our new translation property to take our inverse Laplace transforms, except for one was just a regular inverse Laplace transform. So that's everything that happened in that problem. It was a very long problem. Thanks for sticking through it. We're going to discuss our next property right now, though. So the second property that we're working with is, instead of having our s minus a, where the translation is in the s domain, we're going to have t minus a, as the translation is in the t domain. And to work with this property, we need to make sure that we understand what the like capital U was. It was a unit step function, or you might call it a Heaviside function. And it's given by capital U of t minus a is equal to 0 up until t is equal to a, and then it's 1. Oops. It's 1 after t is the same as or bigger than a. And what that's going to look like is sort of, here's t, here's some a, here's 1, and here's what u does. And so it's 0. Oh, I should use a different color. It's 0 up until a, and then I think I decided there's still a 0 there. And then it jumps up to 1 at a, and then it's 1 after that. I used a curly line just so that you can see it over the black line if this color doesn't look different from black to you. But it's supposed to be a straight line. And so the way that we use this in Laplace transforms is kind of to represent piecewise functions. With shifts at t equals a. So if we want to take the Laplace transform of some f of t minus a, u of t minus a. That's going to be equal to e to the minus as capital F of s, where the f of t minus a, u of t minus a is going to look piecewise. And what's going to happen is up until a, it's just going to be 0 because u is 0. And then after a, it's going to look like f of t minus a. And I know that this is going to be challenging for people, this representation, so we're going to work through a couple examples. So we're just practicing writing piecewise functions with u. And so we're going to start with, we want to have f of t equal to 0 up until t is 1. And then after that, we want it to be e to the 3t. Did I use all my symbols right there? Yeah, I did. Okay. So that's what we want our function to be. And if we were kind of like drawing this, what it does is it starts at 0, and then at 1 it switches. So it looks like 0 up until here. And then at 1, it shifts to e to the 3t. So it looks kind of like that exponential. And what we want to do is use this u of t minus a to represent it in a new way. That bracket was a little tall. So I want it to look like something that I know how to take the Laplace transform of. So I have to multiply something by u of t minus a that represents this f of t. That's my goal here. And so first off, I know that my a is 1. So we can go ahead and I guess just write that down. U of t minus 1. And then I could say, okay, maybe that's supposed to look like e to the 3t. Then what that would look like is before 1, it would be 0 because u of t minus 1 is 0. And then after 1, it would look like e to the 3t because u of t minus 1 is 1 after that point. So that's correct. That is what I want to have. The only thing is that I need to have f of t minus a whenever I have u of t minus a. Since I have u of t minus 1, what I actually need is for this to look somehow like t minus 1. So I'm not quite done yet. So I want to have some kind of f of t minus 1 right there. So how am I going to do that? Let's see. If I have e to the 3t, but I want it to look like t minus 1, then that's going to give me my 3t, but now there's an extra minus 3. So then I just have to add 3 on. Now this becomes something that looks like t minus 1, but when I multiply everything through, I haven't changed anything. 3t is the same as 3 times t minus 1 plus 3. So I'll go ahead and make a note right there. Looks like t minus 1. But e to the 3 times t minus 1 plus 3 is just e to the 3t minus 3 plus 3, e to the 3t. So my function hasn't changed. It's still the same as what I knew it needed to be before. So that would be my final answer. That I'll go ahead and erase my brackets at this point. my f would be that thing right there. And so if I was thinking about taking L of e to the 3 times t minus 1 plus 3 u of t minus 1, I know that I could use this property right here, that it's e to the minus as f of s.